The purpose of this video is to run through how to control an induction motor using a VFD over Modbus. And this is something that's always interested me. Basically, learning how to get the control exactly how I want using the Modbus protocol is definitely very common. And what I've done over the last little while is put together like a Modbus library for use with C#, so that HMIs can be used or some kind of interface can be used kind of at my comfort in that regard. So I have a small setup just down here where you'll be able to see it's a blower. And then basically what we have is we have a VFD here, and then we have an energy meter across here. This guy then is called an Ethernet to RS485 converter, and then what I have here is a USB to RS485 converter as well. So the USB to RS485 is controlling the VFD, and it's just only wired up where you can see these are two wires that represent the minus and the plus, or A and B of RS485, and the exact same then is done across here with the energy meter, and the energy meter then is just pulling back the basic values of current and so on. So this setup here is just to show both of those kind of communication methods, for the purposes of gaining that kind of control. To start, I think before going into kind of anything more technical, what I'll do is I'll start off with kind of like a demo. So I have a small application here, which is part of a kind of a larger application, by where I can control the VFD, and I'll explain the function of this guy in the background. Essentially what I'm doing is I'm setting the frequency in hertz, which basically is something that means that the induction motor is exposed to an alteration basically in the sine wave, which allows the motor to move at kind of like a different pace. So I'll give an example of this. See this guy that's set, it says 15 at the moment. Maybe we'll just change it and we'll just set it to maybe just that guy, just about 10 for example. And then I'd hit this run command here, and you'll see the motor begin to turn. And effectively then I also have a secondary application which is going to pull values back from this energy meter. And in the energy meter, when it sends certain particular values at certain Modbus addresses, it gives back different values. So here, pulling it back, this is actually only taking back 0.68 of an amp. So what I'm going to do now is I'm just going to up the motor output. I'm going to change the speed. So I'm going to change this guy here, and you'll see that the reading, it's changed to actually 25. So give another energy meter read, and you'll see now it's gone up to 1.46 amps. And this is kind of just how this Modbus principle works here. I send commands. There are so many different channels here which are available, which could be used with a multi-core cable, but here instead we're just sending the different commands as you would get off kind of like a data sheet. So I'll just turn that guy down there. Just stop him entirely. And I'll step through kind of a bit more of the code in C# and kind of talk a bit more about kind of Modbus. This video is being done alongside a blog, so there'll be a lot of detail which isn't included in this video, which will be included in the blog.
When I was doing out the blog, and when I was kind of getting my thoughts together for this video, I was very much thinking of how would I explain Modbus to someone who's never seen it before, right? And obviously the audience can be very broad and so on. And I've kind of wrestled with how I should kind of approach it. But look, here's my best effort anyway. So explaining Modbus is very much a case where I have to kind of give out the concept of Modbus having different devices, right, on a kind of a network, where the different devices will have different IDs. So you might have device number 1, device number 2, etc. So that's just kind of like your first protocol. And a Modbus command, if I was to show an example of it, it would be this. So basically we would have, say, device number 1, right, of which you can have many devices, right, and go up. And then you have different, different commands, right? So you can have like a read command or a write command, etc. So here 06 function number 6, if you can think of in your mind, function number 6 represents writing data to a register, and then there's basically a value to come. See, as we have here, 03 is read data from a register, different parameters which are held inside the VFD. Okay, so, and then what you normally have is you've got some form of an address, and here we can see this guy 2000, that represents an address that represents the run command. And then we have, say, 0001, that represents, telling it to go, right? So when you're going down through your data sheet, what you will see a lot of is say, areas that will begin to make sense, kind of in this sense, right? So here, say, for example, if we have the 06, which is the writing command, we have a parameter here, which is basically it's down as 2000, but when I kind of look at it in hex, I think of 2000. That's what the H is standing for. So if I give on a parameter of 1 to it, it means run. And if I give, say, for example, if I give a 7 onto it, it basically puts it into stop. Okay, so then we can see that, say, for example, 2001, that means changing the frequency setting, and then we would obviously give it a value where we would kind of change it, and so on. And when you go down through the data sheet, you will begin to see different parameters that kind of make sense. Okay, so for anyone who doesn't understand hex or hexadecimal conversions, I'd certainly say go and take a look at it now, and then come back to exactly where you are here in the video, in order to get things to make sense. So if I say in the blog, you're going to see this section here, which is going to give an example on how to start the VFD. We basically have to understand that if we wanted to give it a go, we put this parameter here, we'd give it this value. And as you'd see in the data sheet, again, we'd have a parameter address, and then we would give it this value for run, etc. And then this value for stopping the run. Okay, and what I'm going to do now is cross over into the actual code, where I'm trying to make things easy, because the average person who's going to be looking at this has probably never seen Modbus before, or they just want to kind of learn how the library that I'm going to talk about further kind of makes sense. So essentially, in terms of the library and how it works with C#, sorry, just a moment there, with the library and how it works with C#, I have two methods of working with devices out in the field. One is where I'm using a COM port, and then the other is where I'm using a Modbus TCP server, right? So I'll kind of elaborate further on that. This is the library that I'm talking about here. It's called APP Modbus. So I'll stick with the COM port example first. So in terms of writing out to a device, and if I want to kind of map it together, here, say, for example, I have an identifier of 2, and then what I have then is I have just a write command. So if you can see here, or sorry, a read command, where I have this would represent the 03. So if I open this guy up, I can see that this guy is 06, that would mean write. If it was 03, that would mean read. Okay, and then what I simply have is all you have to do is pass in the address. And if I actually open up a different screen, it would be better if I actually did that. Just a moment there. If I pass in an address and then just simply a value, then I'm able to get what I want. So this guy here, in terms of my identifier, I set my identifier, then I have a method which represents, say, for example, writing or reading, and then I just have an address and a value. And that completely then corresponds onto the concept of, the concept of device identifier, whether I want to do a read or a write, the parameter, and then the address. So in terms of the library, I've tried my best to try and make things as easy as possible to understand. Okay, so what I want to do next is I want to just kind of give you kind of like a heads up where what will come further on is the library expanded out to a TCP server, but I'll talk about that kind of at a further time. So when you're opening up using the COM port method, it's very much the same for RS485 as it is for RS232. You basically have to go off your device manager, and in your device manager you're going to find that as soon as you've used a certain type of device, like say USB to RS485 converter, you're going to get a COM port, which a driver which basically gets installed. And an example of that then would be, say for example, where we have, it's this guy here. Say this is a very, very cheap device where you basically just plug it in and the COM port will come up, and then you just wire your minus and your plus, your TX and your RX basically come out of this and into the device. And it's very much the same then when you use, say, an Ethernet to RS485 converter. You basically have these 3 pins here, and they effectively go out into the device, and then you have a device which is accessible over the network. Now you can use it basically what's the right way to say it? You can use a standard Modbus TCP server, but you can also use something called a virtual COM port as well. So many of these devices will actually come with some kind of virtual COM port package, and I'll kind of explain further what that means. So here's an example where you can see this virtual serial port which has come up, and I will talk a little bit about how you set up those Ethernet devices now. So if I go here, just take a look at this guy here. If I take a look there, what I'm going to see is a COM port which is basically in use. And then if I open up this web page, what I'm going to be able to do is actually log on to my device, okay, which has a set a known IP address. So effectively, this guy is something that you can actually log on to, and you can actually configure it, you know, as is needed. And basically, one side is very much the part that connects to your standard network, and then the other side then is basically where you're configuring an RS485 port, you know, in the standard sense. And what you have to do is make sure that all of your settings that you would normally have set for other COM ports here, that you actually set them out on the actual the Modbus or Ethernet RS485 converter. And this is really, really important. So what can happen then is that you have effectively set up a circumstance where you have a virtual COM port where you can just simply take the code that is relevant to the COM port send, and everything else is taken care of for you. You don't have to specify out the IP address or the port, etc., you know, of the device, and then have the conversion occur out of that area. The Modbus device over the Ethernet network actually thinks that it is connected to the PC through a COM port, and you get all of the advantages of keeping the code very, very simple. That's kind of like that's something that I will elaborate more on. I think anyone who would listen to that, who the first time coming here, would very much kind of still be kind of scratching their head a little bit. It's something that has to be broken out over several blogs, and I think that there's blogs that absolutely have to be dedicated towards the converter being done properly and explained further. But that essentially is kind of where things sit. This library will be developed further for commercial use, and you know, hopefully what I'll do is I'll put various blogs out in the coming weeks on that. Thank you very much.